The remainder theorem for division states that if you divide the polynomial function p of x by this factor x minus r, then the remainder r is equal to p of r. And so we're going to see that by using two different methods to solve or find a value for a polynomial function. The first method is substitution, and the second is synthetic division. So let's look at this polynomial function p of x, which is equal to 5x cubed minus 2x squared plus 4. Let's first find p of 3 using our method of substitution. So we'll plug in our value of 3 for x. So we have 5 times 3 cubed minus 2 times 3 squared plus 4. Then if we solve this, let's simplify a little bit. We'll work our exponents first. So let's go 5 times 3 cubed, which is 27, minus 2 times 3 squared, which is 9, plus 4. And then we have 5 times 27, which is 135, minus 2 times 9, which is 18, plus 4. Work our subtraction and our addition, and we get 121. So our value, p of 3, for this function is 121. And this is our remainder. Let's see if we get the same thing by using synthetic division to solve for this function for p of 3. So when you're asked to find p of 3 for this function, it's the same as dividing by the factor x minus 3. So we can set up our synthetic division as this. We put our remainder up here in the corner. Let's pull down our coefficients of our terms. So we'll pull down 5 as the leading coefficient. Negative 2 is the coefficient for our x squared term. We don't have an x term, so we're going to put a coefficient of 0. And then we have our constant, which is 4. So for synthetic division, let's pull down our first coefficient here to 5. And we're going to multiply 3 times 5 is 15 and put it here. And we're going to add these two. We've got negative 2 plus 15, which is 13. Then we're going to multiply 3 times 13, which is 39. 0 plus 39 is still 39. Then one more multiplication, 3 times 39, which is 117. And you add 4 plus 117, and we get 121. So our remainder, using synthetic division, is the same, 121, as when we found the value of p of 3 using substitution. So now let's move on and we'll talk a bit about the factor theorem. The factor theorem for polynomials says that the factor x minus r is a factor of p of x if and only if p of r equals 0. So we can answer a question such as this: is x minus 5 a factor of this polynomial? 2 times x cubed minus 8x squared minus 7x minus 15, by using our short form of long division for polynomials, which is synthetic division. And then when we use synthetic division, we're only concerning ourselves with the remainder. If that remainder equals 0, then we can say that this x minus 5 is a factor of this polynomial. So let's set up the synthetic division. We are going to divide this polynomial here by x minus 5. And our short form looks like this. So we take 5, and then our coefficients from our polynomial. So our leading coefficient is 2. The next one is negative 8. Next one is negative 7. And the constant is negative 15. So we have all of our terms covered there, okay? So then we're going to bring down our 2 here and then multiply. 5 times 2 is 10. Then add here. Negative 8 plus 10 is 2. 5 times 2 is 10 again. Negative 7 plus 10 is 3. 5 times 3 is 15. And look at that. Negative 15 plus positive 15 is 0. So our remainder here is 0, which means that we can say, yes, x minus 5 is a factor of this polynomial here. Let's talk about the number r. Now we can give r a special name, and that's called a zero. So the definition for a zero is if x minus r is a factor of the polynomial function p of x, then r is a zero of that function. We can restate this definition saying if p of x and p of r equals 0, then r is a zero of that function. So we have a few different terms here and they can get a bit confusing. So let's see if we can clarify them. We're dealing with factors, we're also dealing with zeros, and then solutions too. So when we talk about factors, we're talking about polynomials. And let's say we have the polynomial x squared minus 5x plus 6. We know that we can factor that polynomial into two factors, x minus 3 times x minus 2. Now since we have these factors, we know that p of 3 is equal to 0 and p of negative 2 is equal to 0. So this polynomial here not only has the factors, but they also have zeros. Now when we set this polynomial in terms of a function, so p of x is equal to x squared minus 5x plus 6, this function also has zeros because we can say that p of 3 is equal to 0, or p of negative 2 is equal to 0 as well. Now moving on to polynomial equations, when we have p of 3 equals 0, we know then that x equals 3. And x equals 3 is an example of a solution to this equation if we were to set p of x equal to 0. So say we have x squared minus 5x plus 6 is equal 0. This is now an equation. The solution to that equation is x minus 3. So that's a little bit of clarification for these terms which can get a little confusing. So now let's put this to the test and try an example. Okay, suppose you're asked to find all of the solutions to this equation. 12x cubed minus 47x squared plus 28x plus 15 is equal to 0. And then we're given that x equals 3 is one solution. So that's helpful that we have one solution to start off. Now, since x equals 3 is one solution, we can also say that 3 is a 0 to this function. And then we can say that x minus 3 is a factor of this polynomial here. So we can divide this polynomial by this factor in order to start to simplify and find our other solutions. So let's use our short form for long division for polynomials. We'll use synthetic division in order to divide this polynomial here by x minus 3. So let's start with 3 in the corner and then bring down our coefficients. We have 12 and negative 47 from this term, and then 28 and 15. We're going to bring down 12 here, then 3 times 12 is 36. We add negative 47 plus 36, which is negative 11. Then 3 times negative 11, which is negative 33. 28 plus negative 33 is negative 5. Then 3 times negative 5 is negative 15. 15 plus negative 15 is 0. Now that works out with a remainder 0 because we know that x equals 3 is a solution, therefore x minus 3 is a factor, so there shouldn't be any other remainder other than 0. Now up until now in this section when we've been working with synthetic division, we've only been concerning ourselves with the remainder, but this is important here because we're going to use this solution in order to create another factor for this function. So now, using what we found here, we can write that this polynomial equation here is equal to x minus 3, which is from one of our solutions, and then this part of the answer here in our synthetic division becomes 12x squared minus 11x minus 5. That's all equal to 0. So now we have one solution here, this is one factor. Let's factor this polynomial inside these parentheses here in order to find our other solutions. So we have x minus 3 still, and then this polynomial here factors to 4x minus 5 times 3x plus 1. and that's all equal to 0 still. So now if we set each one of these three factors equal to 0, then solve for x in each one, we'll get our solutions. So we know x minus 3 equals 0. That gives our solution that was given in the original problem of x equals 3 here. Let's set 4x minus 5 equal to 0, and you solve for x, and you get 5 over 4 as our second solution. Now let's set 3x plus 1 equal to 0. Solve for x, and you get x equals negative 1 over 3. So using synthetic division and then finding our factors, simplifying, we've got three solutions here to this polynomial equation. We have x equals 3, x equals 5 over 4, and x equals negative 1/3.